Alright, so now let's do the solutions for the remaining problems on assignment 34. The only ones I won't do are the graded problems, which are similar to the problems I will be doing. On number 14, we've got a polynomial that's in factored form. First of all, let's find the end behavior. Well, first of all, to do that, we need to find the degree. So we want to add the coefficients of each factor. So 1 plus 1 plus 1 plus 2, we're going to get a degree of 5. And since it's a negative 2 in the front there, we are going to have the opposite of the end behavior of x cubed, which we've been calling the John Travolta. So it looks like that. The zeros is pretty easy to find here because it's in factored form. So remember, if x is a factor, then 0 is a 0. We also have 1, negative 3, and negative 5 as zeros. And so we have corresponding x-intercepts here. So first of all, for 0, 0, since it's x squared, our multiplicity is 2, so we're going to bounce at that x-intercept. And each of the others are to the first degree, so they're going to have a multiplicity of 1 and a behavior, well, they're going to cross at the intercept. So now let's go ahead and draw the sketch. We can put in our x-intercepts. We've got our end behavior. And then remember, we want to go from left to right. And we're going to cross until we get to 0. So cross, bounce, and then cross. So your graph's going to look like that. Alright, let's move on. So here it says identify the x-intercepts from the graph and use them to write a possible equation for the function. Alright, so first of all, we're going to write a function for this. We've got a 0 at 1, so we know that x minus 1 is a factor. And since it crosses at that intercept, we know we're going to have an odd-powered factor. So we just say to the first power. Now if we look at the other point, or the other x-intercept at 5, we're going to have negative x minus 5 as a factor. Because it's bouncing, we're going to have an even power. We'll just use 2. Now, we know this is a degree 3 polynomial that we just wrote. And that's what we expect as far as end behavior. We have, we're rising on the left and falling on the right. But this is the opposite of, first of all, it is degree 3, but it's the opposite of our x cubed function, or the John Travolta. So we're going to have to put a minus in front of our function to account for the fact that the end behavior is as it is. Let's move on to B. So notice negative 4 is a 0, or a x-intercept, so x plus 4 is a factor. Because we're bouncing there, we're going to say that it's squared, or any even power, but we're going to use 2. And then we also have 1 at negative 1, so x plus 1 is going to be a factor, also bouncing there, so we'll say squared there. And so this has a degree of 4, and it opens up on both sides, so our coefficient out front is a positive 1, which is what it should be since this thing opens up on both sides. So we're good. Let's move on. Alright, so now we have a few review problems to do. Number 16 is an order of operations problem. We want to square first. Next thing we want to do is multiply. Remember, additions and subtractions come last. And so finally we end up with 76. Number 17 is FOIL in disguise. We don't have any rules of exponents for this one because of that plus in between. We have two terms there. All we can do is write two of these x plus 4 factors and then FOIL, combine our like terms, and we're done. 18 is the same type of problem. Let's FOIL it out. And our final answer is 9x squared minus 30x plus 25. On number 19, this is a lot like, and by the way, we're not going to use substitution, but it's a lot like x squared minus x minus 6. We're going to treat it the same way. This is one where we can use the AC method. We're looking for two numbers that multiply to -6 and add to -1. -3 and 2 is what's going to work. So I've done a similar problem. This one's just a little bit different. So instead of x and x like we had in our factors for the one I just did, we're going to have x squared and x squared. Otherwise it's the same. If you FOIL this out, you'll see that it does equal the original. Alright. Now, and I do want to point out on number 19, I'm using the shortcut with the AC method because we have a 1x squared and we also have a 1x to the 4th. On number 20, we know when we divide a polynomial by a monomial, we can write each term over our denominator here. And then we just simplify each of the terms. So you should get 2x minus 4 minus 3x. On number 21, we're going to use the quadratic formula. But first, let's add 9 to each side. Now, keep in mind, if you try to factor this, it doesn't factor. You can't find two numbers that multiply to 9 and add to -4. So the quadratic formula is all we got. With quadratic equations, we'll always try to factor first. But if we are not getting anywhere, then we want to use quadratic formula. So I'm plugging in the numbers here. And let's simplify. Now, square root of -20, we can simplify this radical. You're going to end up with 2i square roots of 5. So let's rewrite this as 4 over 2 plus or minus 2i square root of 5 over 2. And so finally we end up with 2 plus or minus I times square root of 5. And that is the end for this video's solution set.